Hello everybody, welcome to the Java course. When we talk about exceptions, there are essentially two types of exceptions. The first type is called checked exception, which means that the exceptions would need to be checked by the compiler, and you have to make sure that you have to handle the exceptions if they are checked. And the other type of exception is called unchecked exception, which means that the compiler won't check those exceptions for handling. In this video, I'm going to talk about the checked exceptions, and I'm going to show you an example of handling the checked exceptions. Before doing so, I need to elaborate on the term checked exception. Checked exceptions are usually the exceptions that are not the fault of the programmer. Also, checked exceptions are expected to recover by the final user of the program. We have one simple example of checked exception. I/O exception or input-output exception is a type of checked exception. What does it mean by that? When we talk about input and output, we usually refer to some files, but for accessing the files, we may not be able to do so easily because the file can be corrupted or the file can be lost due to some reasons that are not controlled by you. And when this situation happens, you would usually ask the user to wait for the file to be complete before you can play with it, or you can simply get the file back to the file system. So for the I/O exception, you can expect the user to recover the problem by doing some actions. And in this situation, we will say that the checked exceptions are not the fault of the programmer, but the problem with the final user. If the final user is able to recover the situation, the program can still be run. So the checked exception refers to this kind of situation, and the video is going to tell you the way to handle the checked exception. And I'm going to talk about a little bit the unchecked exception. What does it mean by the unchecked exception? We can elaborate on this term. Unchecked exceptions are those created by the programmer at runtime. What does it mean by that? We can see some examples of unchecked exceptions. Arithmetic exception and null pointer exception are two of the examples of unchecked exceptions. What does it mean by these two types of exception? For the arithmetic exception, it usually refers to the problem with handling the user input. For example, when you want to divide something by 0, you cannot do so. You will usually have the issue of arithmetic exception. And for null pointer exception, when you don't really create an object, or your reference variable to a certain object is simply having the null value, you cannot really tell the object to do something for you. In this case, you will have the null pointer exception. So you can see that these two exceptions should be avoided by the programmer during the design process of the program. So in this case, they are regarded as unchecked exception because Java leaves the responsibility of handling these exceptions to the programmer. So unchecked exceptions are not forced by Java virtual machine to handle. In fact, you can really call the default exception handler of Java virtual machine to help you handle the unchecked exception. Usually, the default exception handler will simply stop your program at the place where the unchecked exception occurs, and you cannot further continue running your forthcoming code. So remember, for unchecked exceptions, you, as the programmer, have the responsibility to handle them. And for unchecked exceptions, the programmer should also need to handle them as requested by Java system. Okay. Okay, for checked exceptions, you must either handle or declare them, and I'm going to show you both processes for checked exceptions. For now, I will show the handling of checked exceptions first. Suppose I will start with my main method. Suppose I want to read a text file. Before doing so, I need to create a scanner object, and I have to import the scanner class first. Okay, and then I can let the user enter the input file for me to read. I will have a variable called file name, which is going to store the reference of the string that refers to the file name that I'm going to access. Okay, I will give a prompt, and then I will store the name of the file to the variable file name. I will use the next line method of the scanner object. Okay. So in this situation, it is possible that the file does not exist in your file system of your workspace inside the Eclipse environment. So it is possible that you need to handle the situation when the file is not present or the file is corrupted, something like that. So for my example, I'm going to check the situation of whether the file is present or not. So I can do something like this in my try block. Here I want to create a software file object, and the reference variable to this file object is called input file, and the input file is simply pointing to a file object referring to the file name that the user input has given me. Okay, so I need to import the file class before doing so. Okay, java.io.file refers to the file class that I'm going to use. And then I can do something like this. If my input file really exists in the folder here, I can simply say that the file exists. If the file is not present, I can do something like this. Okay, I can simply throw an IO exception object whose message is file not present. And the throwing action needs to be handled. So I need a catch block followed by the try block. How can I do that? I'm going to catch the IO exception object thrown by the try block. Okay. Okay, I'm able to say that the users should check the folder corresponding to the file system for your project. And I'm also able to print out the message coming from the IO exception object thrown by the try block. Finally, I'm able to print out the stack trace of the IO exception object, whose reference variable is called EX. Okay. Of course, I can do the finally part for my program. Okay, in my finally part, I simply close my scanner object created previously, and I'm also able to print out the end of program statement. Okay, now you can see that my project folder has no any kind of text file shown on the directory, and you can also check this issue by looking at the folder of the directory under the Eclipse workspace. So this is the project that I'm going to play with, which is checked exception, same as this folder. So under this folder, I have no text files. So we will expect that the IO exception will occur. That is this exception. So let us see this situation when I run the program. Save and run. And before I run it, the IO exception is already imported for me automatically. This is the property of Eclipse environment. If you forget to import some kind of exception classes or any other classes, it can help you to do so. So if you don't remember to do this line, it is still acceptable. So let me run it. Suppose I want to check the presence of a file called abc.txt. When I press enter, I will have the following response. When I run this line of code, I will get the file name from the user input, that is this string. And then since that file is not present in my folder, I will simply go to the else part in the try block, which means that I will throw an IO exception object. And when the exception object is thrown, the catch part corresponding to the try block needs to handle the exception object. How does it handle the exception? It simply says that the folder has no such file. And the catch part is also able to show the message coming from the IO exception object. So the message is simply this one, file not present. And the stack trace of the exception object is simply this one. I have got an IO exception object, and the reason for getting this exception is simply the absence of my file. And the line which makes this happen is simply line number 32, because I have thrown an IO exception object. So this is the case when the file is not present. Let me try to put that abc.txt file into the file system, and let us see the execution again. I have a text file. Let me copy it. And let me paste it to the project folder. And let me try again. abc.txt. Now the file exists, and I'm able to show the end of program, which comes from the finally block. Why will I have the output like this? Because the file is present. I simply say that the file exists, and I don't really throw an IO exception object, so the catch block doesn't need to be executed. I will simply go to the finally block, which tells me to close the file, the scanner object, and print out the end of program statement. So this is the situation when we really handle the exception by using the throw keyword together with the catch block. Okay, so this is one way of handling the check exception. Now I'm going to show the way to declare the checked exception. So let me say something here. Now I'm going to use another type of method signature. Okay, here I'm going to declare the exception. And then I will let the calling method of the method to handle the exception. So now the calling method will be the main method. Let us see what I will do to the main method. First, I need to add these two words more to the after the method signature of my main method. Okay, throws IO exception. So we will expect that the main method can throw an IO exception object. And then since the main method can throw an idle exception object, the catch part previously might not need to be present. So in this situation, when I want to declare an exception, I don't really need a catch block to really handle the exception object. If the main method really throws an idle exception object, I will let the calling method, which is simply the Java virtual machine in this case, to handle it. So let me try to run it again. Save it. Run it. Here, my text file is still present, so I don't really need to throw an idle exception object. That will be thrown by the main method later. And then I can say that I need to end the program, and I'm able to close the scanner object. So let us see the situation when the file is not present. So let me delete it. Okay. And let me run it. Okay, the file name is abc.txt. And let me try to press enter. Okay, when the file is not really present in my project folder, I will really throw an IO exception object with this message, and the main method is able to throw the IO exception object created by me to the calling method, which is simply the Java virtual machine. And the Java virtual machine will simply say something like this. I will have exception in thread main. I have occurred the IO exception. The meaning is that my file is not present, and the problem lies on number 35 of my code. Okay, and we can see that the program is able to do the finally block by closing the scanner object and by printing the end of program statement. So here is the part handled by the default exception handler of Java virtual machine instead of handling by the programmer. Okay, so in this situation, when the main method can throw some exception objects, the calling method of this method will handle the exception. Okay, so in this case, my Java virtual machine is the calling method of the main method here. So the Java virtual machine will need to handle the exception object by creating the messages here from the default exception handler. So we can see the situation of both handling and declaring the checked exceptions in my example. I hope you're able to understand the two approaches, the one to handle the exception and the one to declare the exception and let the calling method handle it. This is the end of the video. If you have any questions about my video, feel free to leave your comments on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.